Hey guys, let's do another one of these work energy problems. And this one, I didn't have the problem drawn beforehand, but here it is. So we've got this curved guide, and we've got this slider that slides on it. Now, the slider is being pulled by a rope. And you can see the rope right here, it's the pink line. And the tension in that rope is 1.3 pounds. So that'll be the force that's applied to that slider that causes it to move up here. Okay, and you can see all the lengths given there. Now the weight of this slider is going to be 0.6 pounds, and we're told the slider is initially at rest at A, which this is A right here. We want to find what its speed is at B. All right. So first things first, let's go ahead and draw the free body diagram. All right, we've got weight. So that's going to be the 0.6 that was given. And then we also have the tension due to this cable, right? So that's going to be like that. And I'm just going to use the standard XY system on that one. Now what we're going to do, we want to find velocity. So we're going to relate work to velocity using the kinetic energy equation. So remember we have that. That's what we're going to be looking for. First, let's find U. So these are this is the work equation. So we got to look at the external forces, see which ones have work. All right, so let's start over here. So as I'm going from A to B, if you look, let's think about this force here. Is this producing work? Do we got work for this one? We do, right? Because we're moving up 10 inches. So there is a work there because there is a displacement in the same direction as this force. All right, so we've got that. We need to put that in here. And the displacement is in the direction opposite the direction of the force. So it's going to be negative. So we get negative 0.6. And then I need my distance. This is in inches. We need to convert that over to feet. So that's going to be 0.833 feet. So multiply those together. Next, we've got this 1.3 pounds. Well, obviously the slider is moving in that direction because it's pulling it in that direction. All right, so we're going to have a plus because the displacement's in the same direction. So I have plus 1.3, and then our distance, we got this 6 inches here. That's given, and then this is 24 inches. So I'm going to B, right? So I'm going to do the 24 inches minus the 6 inches. And then basically we're going to find a triangle, right? So I want to know this distance right here. Right? We're going to assume that's the distance that we traveled. So for that, let's have the square root of 2, which is from that. And then let's make this 0.5. So I have 2 minus 0.5 squared plus 0.833 squared. All right. So that'll give us a rough estimate of our distance traveled in the direction of that chord. All right, it's not perfect, but it'll be good enough. Okay, so now we've got that. Now simplify all of this. You get 1.73. Now I'm going to take this, and it goes right here. So we're going to have 1.73 equals 1/2 times the mass, because remember T is 1/2 mv squared. So we're going to have 1/2 times the mass, which is going to be 0.6. Now that was weight, so we divide by gravity, 32.2. And then we're going to have VB squared minus VA squared. Well, VA is 0. All right, so VB, now you can solve for that. And you get 13.63, and that is feet per second. All right, so that's your speed when you get up to point B. All right. And that was a short video, so let's do this next example just to get it done. So this one, we're going to have like a ramp. Let's say it looks like this. We're going to have a box. So we've got this box at A, and it's going to weigh 64.4 pounds. The speed at A is 3 feet per second, and then it's going to slide down this hill, and B, the speed at B will be 25 feet per second. All right, so let's say that B is right here. All right, so we've got 25 feet per second here. Up here, it's 3 feet per second. Now the difference in height here is going to be 20 feet. And then the difference in X, 30 feet. Okay, now I want to know what is the work done by friction. Okay, so as we go down this surface, it's a rough surface, it's going to have some friction here. I want to know what the work is done due to that friction force. All right, so let's go ahead and draw the free body diagram. Should always be the first thing we do. So for this one, we're given the weight. So you can just put 64.4 pounds. And then we're sliding down this way, so friction's got to go up like that. And that's going to be mu times n. All right, so now we've got that. Now I need to look at this and figure out my work equation. Okay, and again, we're going to say work's equal to the change in kinetic energy. So now with that, let's do the weight first. So the weight, obviously we're moving down in the same direction as the force for weight. So we're going to have 64.4. The displacement is 20. And this is positive because the displacement, since we're going down, is in the same direction as the force itself. Okay. Now the friction force, that's what we're looking for. So I'm just going to call this u sub F. And this is negative because I'm going down this way, friction's going back that way. All right. So now we're going to set that equal to 1/2 times the mass. So that's going to be 64.4 over gravity times the final velocity squared, so 25, minus 3 squared. Okay, so now simplify, you get 1,288 minus the friction, and then that equals 616. So your work due to friction is going to be 672. And that's foot-pounds. All right, so that'll be your work due to friction in that problem. Okay, so the key thing here, when you're finding work, you've got to have a displacement in that same direction as the force. It's the main thing here. Okay, guys, that's it for this one. I will see y'all in the next video for potential energy.